Morning.
Hello.
Hi, how's it going, Stuart?
Not so bad. I've got two of you here. What's going on here? Oh, you joined
Yeah,
from your Vodafone machine as well.
yeah, it's from my Vodafone machine as well. Yeah, so I can also co-pilot as well and transcribe if that's okay with you.
Yeah. Okay.
No problem. But yeah, thank you for joining. Yeah, basically, I'm trying to create a low-level design for this red vulnerability remediation solution, which includes deployment of two active servers within AWS. So
Right.
I kind of like need some clarity on the physical and the logical network connectivity between the red network and the services in obviously the STP services in AWS. So if I kind of like show this diagram that I have, just give me one second.
Yep. Okay. Looks familiar.
Oh, you've seen this before, this one? Yeah.
I've not seen that diagram, but I know the infrastructure yet.
Yeah. So kind of like I wanted to kind of also like get a handoff point confirmation, like based on the design. Obviously, the connectivity uses AWS Direct Connect. So can you confirm like the exact uh, physical and logical point of handoff from the Vodafone managed layer 3 switches to the EDF AWS managed platform at LD5 and LD8, and where the routing obviously takes over.
You need to be more specific there. So
Yeah.
you're doing an LLD for a solution.
Yeah.
Which is basically firing images from SFTP servers in AWS onto switches on the on-premise red network.
On-premise red network. Yes, that's correct.
Right.
Yeah.
Okay. And at a high level, what you have there, red network into there. Yeah, that's almost right. Yeah, okay. And that goes to Equinix and into AWS. Yep, agreed. Okay. So I think I tried to suggest this in my response to you.
Yeah.
The the AWS connectivity was provided by the Diamond project and is common to all usage of AWS and Azure for both red and blue networks. So it is a whole solution in and of itself, and everything else takes it as implicit and makes use of it. So and I can be reasonably confident that there's half a dozen new things stood up on that every month. So I can help you understand what it looks like, but I feel quite strongly that you shouldn't document that in technical detail in an LLD that's just going to make use of what's there.
An LLD as well as like a HLD as well. So
yeah, and my rationale for that is that that documentation already exists and is available, and if something changes in that environment, that's the only place anyone's ever going to update it. So we don't want that. We don't want that level of detail going into PDDs that end up being out of date.
That's
yeah.
Is there like a file? Okay, if possible, if you can share me like file locations as well for that one, so I can kind of reference it back into use that as a reference point on.
Do you have access to EDF Confluence?
Oh yes, I do. I do have access to that. Yeah.
Okay. Let me just drop a link in this chat and see if you've got access to the space. So it's in the. I assume it's still called. I know it's in the Vodafone Services space now. It used to be in the Project Diamond space. I just follow that link in the chat and see if that gets you to where you need to be.
Let's do a high-level design and low-level design.
Right. Okay. So you're in the right place. Yep.
Yeah. Okay. Yeah.
And the low-level design in particular. If you look at the page titled Layer 3 Overall, Routing Principles and BGP Design, then it's all in there in great detail. In summary, maybe if I just bring this diagram up, where you're connected from your Blue account and Vodafone here. It's okay. This is not SNI, so that's cool. Okay, so if I'll share this and I'll just give you a quick run through. Actually, let me stop sharing, put that on a different screen so I can see it properly. And re-share. There, go. Right. Okay, so this is a pretty technical diagram, but it will give us what we need. So if you think of this as north and south, in the north we have two CSPs, AWS and Azure, and in the south, kind of at the end of these lines that we've got arrows on where it says Vodafone PE, that is the IPVPN platform. You've then got essentially two identical stacks of kit and tech, one in LD5, one in LD8. LD5 is the happy path. That's where everything runs through when everything is working. And it consists of a MES managed layer 3 switch here that is performing the CE role. So all of these WAN circuits are wires only, and we land them on a switch that we manage and terminate all the VRFs. That then peers up to this layer in the middle, which is a set of EDF managed firewalls. They've got 3 or 4 VDOMs each, and you have essentially this blue block and lines here. This is the HiSec network, or the accredited network, the blue network, which goes to what they call the HiSec VDOM. And then you've got the equivalent for the non-accredited, so the red network coming up off the red VRF into the standard sec VDOM. And these are the security boundary between the on-premise networks and the CSP networks, which are private instances of public cloud, but still considered public, so they're kind of outside of the security boundary. Okay, so these coloured VDOMs, as we'll call them, HiSec, Standard Sec, they pair with another VDOM inside the firewall called Cloud Gateway, and that then pairs with another layer 3 switch. This is what we call the North switch, and then that then pairs with, for LD5, a single direct connection and a pair of Azure Express Route connections. And then you've got exactly the same stuff all the way up on the LD8 train. So a managed switch on the end of wires only WAN, another pair of firewalls, a North switch, and then into AWS and Azure. And then these environments are cross-connected. So these layer 3 switches at the bottom, there are links between them for every VRF. And these switches in the North side, there's a pair of links between them. And that allows us to deal with all of the possible failure scenarios. So, under normal operation, everything's going up and down through LD5. Although I've recently learned we've actually got some asymmetric routing, so some traffic's exiting AWS in LD8, but that's about to be dealt with. And if we lose this CE, then all the traffic comes in here and goes up the LD8 side, gets to the North side, and then is attracted across to LD5 and in to the CSPs through LD5. And that's all done using BGP, local preferences and AS path prepending, just to give us full control of which route is used for what. The firewalls are redundant here, so active standby, just to try and keep traffic in this train if possible, so they can deal with problems and software upgrades and things. And this switch here again is linked across to here. So if we lose AWS, for example, we lose this peering, this physical connection, the cable gets chopped, whatever, then AWS traffic will come across to LD8 and up. The same for Azure, but when you provide Express Route, you have to provide a pair of connections. So I've actually got four routes into Azure. We advertise summary routing from these North switches towards both CSPs, so 10/8, etc. And then half a dozen or so specific non-RFC 1918 addresses as well. That's just stuff that's legacy in the estate or that's routed outside of EDF via Uxbridge or something like that. So we're just sending summary routes in mostly, and we are receiving the supernets that those spaces control themselves. So out of AWS, we're getting 10.128, 10.129/16, something like that. Azure is 10.216, 10.217, I think. All of this has been tested to death, and we regularly, once or twice a year, do a full failover of all of this in order to upgrade. In fact, we've done this just this week in order to upgrade the IOSes on all the switches that are in this stack. We isolate it, so send everything through LD8, work on LD5, and then fail it all back. So we know it all works. In the circumstance where new things are being migrated into the CSPs or stood up from scratch in here, in the vast majority of cases, those things will go into VPCs that have addressing that is part of the agreed schema in here. So if you go to, I think it's TCS that does this, it might be Kyndryl, I can't remember, and say, right, so you say, I need these two servers and they need to be able to contact on-premise. They will almost certainly be given a subnet that's within the established ranges.
Yeah. Well, do we have to sort of provide them with like an IP addressing, etc., or?
I don't know, because I've never gotten involved at that level, but I don't think that's something we would have any bearing over unless there was a need for us to be specific about it.
Right.
So if you went to Kyndryl today and said, build these two servers, they need to run this software and be able to contact on-premise, then I'd imagine their standard process will do exactly that in whatever region is required and whatever the construct is for the VPC and all that kind of stuff, and they'll just give you addressing which would already be part of the agreed scheme.
Yeah.
And so if all of that happens that way, then subject to firewall rule sets, and come to that in a sec, then you would have an established, you would have a access to on-premise via previously established and working routing. So there'd be no changes to be done in this environment anywhere. Your subnet in AWS would get into the routing table. It wouldn't, would it be specifically advertised? I can't remember. But if not, it's part of the summary. And so all of this already knows how to get in both directions, and you don't need to change anything. What you will need to do, and I don't know whether this is something you do or it gets done for you or whatever, is...
I'm involved with Bob Grayson.
Right. Yeah, and Bob will probably know a bit more about it. What you will need to do is to make sure that the traffic is allowed to flow. So inside AWS, I couldn't tell you how all that works.
I think we're using obviously TCP port 22. So
yeah, so you're definitely going to need new rules for that. That's going to need to be done by the people who implement that stuff in AWS, whether that's Kyndryl or TCS or EDF SecOps, I don't know, but someone does something in there to allow that to happen. And then you're also going to come up against rules in this space here on the LD5 and LD8 firewalls that almost certainly will block that today. And so we'll need to get that rule set opened. These things are definitely managed by EDF SecOps. So that would, your project would require a work package to be raised for them to open the rules, and the design would need to specify what from where to where. All that kind of stuff. It's all standard. Just saying that that's definitely a thing that will need to happen. Otherwise, none of this will work. But from the networking, connectivity, routing point of view, there's nothing to do here, as long as what you build in AWS comes within the existing ranges, and I can't imagine it won't.
Right, okay.
If that's not the case, then we would have to This is all BGP here. So all this stuff is flowing dynamically. And if AWS advertises it out, so for some reason we create a new subnet, AWS is advertising it out, this switch will receive and accept it and hand it on. That would be passed down into the colored VDOMs, but at this point here, where we've got F1R, there will be a filter applied through a route map in BGP here that only accepts things that we're expecting. So if there's something new coming, then there will need to be a change here to allow that to get into the on-premise network as a whole. So then we would have to work on some BGP changes for this environment, but I very much doubt we will be in that position. That wasn't a very short explanation, but hopefully kind of sets the scene.
Yeah, kind of makes a lot more sense right now, because I had a few things to go through, but I think you've already went through, like obviously the firewall rule sets, etc., and the traffic flows. Okay.
And in terms of documenting that, I would just reference what we're looking at here.
Yeah, definitely.
Because this is the single source of truth for that information.
100%. That makes sense.
You also had a question about responsibilities. So we know about what's happening in the CSPs. That's all EDF, Kyndryl, TCS, someone else. Excuse me 1 sec. In the Equinix environments, this is all Vodafone except for the firewalls themselves. So Vodafone WAN provide the delivery of the circuits into the space. The account is the customer of Equinix, so the cabinets are ours rather than EDF's, and we pay for patching and cabling and all that kind of stuff. Smart hands, that's all Vodafone. These switches, so there's only 2 switches shown on this because this is layer 3, but there's actually a layer 2 switch that sits in front of this CE. Bit of a bodge for getting cores working. There's a management switch. There's a couple of other switches in here that are involved in this SD-WAN part here. They're all managed by us, by the MES team, and are the accounts responsibility from service point of view. Same with the North switch, and then the peerings that go to the CSPs. The CSP ends are under EDF's control, and they define the, what was it? It's got a LOM or something. There's an agreement that you create that says allow someone to connect on this port. I'm sure it's a LOM. Can't remember. But anyway, these are under EDF control, but we, Vodafone, are responsible for the cross connects. So Equinix provides them. They're managed by us. So it's kind of us all the way up to here, to here and here and so on, with the exception of the firewalls, which are under EDF SecOps management and support. Yeah, it's all this stuff is managed by the Blue Network. Was never supposed to be, but that's the way the project went. So it's although this is essentially a colorless environment in terms of EDF's networks, these things from a management point of view, this is a blue switch, and all the other switches in here have management connection and configuration as if they are blue switches, even though they're not really carrying blue traffic. So yeah, it's a bit of a messy beast.
Yeah.
Gets the job done.
Exactly. Yeah.
Okay. Anything else you need to know? Do you think? If
not for now, but I think obviously it might require another email from me as well. So
yeah, sure.
Obviously
if there's
trying
something,
to inquire more information, definitely.
yeah.
But
if there's
as
more
for
you
now,
need, then just give me a shout. Yeah.
exactly. No, that's very helpful. But yeah,
No
I think for now quite sufficient. But obviously, if anything comes up,
Yep.
yeah, I'll might have to come back. Sorry about the hell up.
Yeah, no, that's fine.
Not a problem.
No problem. Yeah.
But yeah, thanks a lot. Thank you.
No worries. All right. Speak soon.
Thank you. Bye.
Cheers.